All right, good morning. Welcome back to trigonometry here. Today we are going to talk to you a little bit about the tangent function. So we're going to say, okay, y is equal to, let's go ahead and turn on my pen. Y is equal to tangent of x. Now, tangent's a little bit different than sine, cosine, secant. Cosecant, so similar as two, but it's a little bit different. Now, just like those other functions, I want to arrange, we're going to go ahead and think about what points we want to graph for tangent. So if I set x equal to 0, okay, tangent of 0 is 0. Okay, if I set x equal to pi over 4, the tangent of pi over 4 is equal to 1. And the reason why is because tangent is sine of pi over 4 divided by cosine of pi over 4. Sine of pi over 4 is square root of 2 over 2 divided by cosine is square root of 2 over 2. Square root of 2 over 2 divided by square root of 2. That's equal to 1. Okay, let's see here. Uh, when x equals negative pi over 4, we have tangent of negative pi over 4. That is equal to negative 1. And then when we get to x is equal to pi over 2, um, we have sine of pi over 2 divided by cosine of pi over 2. And sine of pi over 2, that's nice. That's 1. Cosine of pi over 2, that's 0. Like, wait a minute, we have 1 over 0. That's not a happy math number there. Okay, that's not something we're allowed to do. That's undefined. Okay, but one of the things we might want to do is we might want to decide what happens as we get close to pi over 2. All right, so I'm going to go ahead and say, well, it's pi over 2. All right, so we can go ahead and do this. We can say pi divided by 2 equals, okay, is 1.5707. Okay, and some more change, but we'll say what happens when we get close to 1.5077. And we'll go ahead and we'll look at what's going on with that. So what happens when x equals, say, 1.5, right? We'll go ahead and just type that in. I'm in radian mode, so, we're looking at like 80 something odd degrees, and we're just kind of looking at that. But, get used to the idea of looking at radians. But we'll say the tangent of 1.5, what's that equal to? And that is equal to 14.1. Okay, that seems a little high. Okay. What happens if we get a little bit closer? What if I go x equals, say, 1.55, right? So we're just going to get a little bit closer. So we want the tangent of 1.55 equals, and then say, okay, that's 48.07. It seems like it got pretty big there. Okay. If we go a little bit closer, I say x equals 1.570. Let's see what happens with that. So tangent of 1.570, 1.570, you don't have to type in the zero, it knows. Okay, get rid of you. Okay, so at 1.570, we go type, so 1,255. Good Lord. I don't know if I'm going to be able to graph this on a piece of paper here because 1,255, I'm going to be graphing this thing through the ceiling. Okay, so let me go ahead and draw us a little bit of a picture of what's going on here. Here's my 0. Okay, here is, let's go ahead and look at pi over 6. Here's pi over 4, pi over 3. Remember, pi over 6 is 30 degrees, 45 degrees, 60 degrees. Pi over 2, that's 90 degrees. And what happens is we get close to this value here. So pi over 6, that's going to be the square root of 3 over 3. So I don't really know what that is offhand decimally, but we'll say that's going to be tangent of, let's see, we have pi over 6. Okay, it's square root of 3 over 3, but again, numerically, exactly what that is, 0.577. Okay, so we'll say that's 1. So 0.577, it's about right there. Pi over 4, here we go, it's 1. Square root of 3 over 2, or sorry, tangent of pi over 3, that's the square root of 3, that's 1.7. So we're going to be up here. Okay, and I should probably have um, changed my scaling just a little bit because that's a huge scale to figure that out. Let me go ahead and do that so I could draw a little bit better for us. Here's 1. So we're here, here, and then here on almost 2. And then as I get close to I'm going to be all the way up here at like 14. We're going to have to scale this all the way up. I don't want to count all of this stuff going on here. So what I want to do is like look at what's going on close to pi over 2. And what's happening here is there's actually an asymptote at pi over 2. Okay, this thing just keeps getting bigger and bigger and bigger and bigger. So when people ask you, like, what's the tangent of pi over 2? The answer is undefined because we're dividing by zero and we're not allowed to do that. That's undefined. But what I want you to think about is like, what if we were a bug? What if we were crawling? Try to draw the cutest bug I can, which is not really that cute, but we're crawling on this tangent. The reason I picked a bug is because they stick to the walls. As we get closer and closer and closer, so inching towards this pi over 2, we're crawling up this almost vertical curve here to see how far we can go up for this thing. Okay, so that's what's happening for this thing. Let me see what happens if we go a little bit past pi over 2. Like, what if we try to do the tangent of 1.58? It's a little bit bigger than 1.57. So if I say the tangent of 1.58, where's my tangent? 1.58 at negative 108. So as soon as we cross over, we're like way down here. So what happens is an asymptote on the other side here. So we're down in these depths as we're getting further and further away from pi over 2 on the other side. We're going to end up back over here. We have pi of 0, pi of tangent of pi. We're going to be back to 0 here. We don't want to, I know that for secant, we did have something that looked like a disjointed graph, right? But the reason why secant looks the way it does is because we want a graph between 0 and 2 pi, because that's what cosine tends to look at. For tangent, okay, we don't have this rule. We have to go with 0 to 2 pi. We could say, well, could we change this to make this like a continuous graph? Like, yeah. So if we end up going from negative pi over 2 to positive pi over 2, and here's my asymptotes, and that's what's going to work there. Those are the points that I want to graph my tangent next to. So the points for tangent, when I want to graph tangent, I want negative pi over 2, negative pi over 4, that's negative 1. This is undefined. 0, tangent is 0. Pi over 4, that's 1. And pi over 2, again, that's undefined. But the way I want you to think about this is as we get close to pi over 2, the tangent tends towards infinity. As we get close to negative pi over 2, we're a little bit above negative pi over 2, so we're marching down. So we're like, say we're negative 80 degrees, negative 85 degrees, negative 88 degrees, negative 89 degrees. We're getting closer and closer and closer, and it tends towards negative infinity. Okay? So when you take calculus, one of the big mistakes that calculus students make is that they tend to treat infinity like a number. It kind of looks like one. And to be fair, we kind of treat it like a number in calculus. But in the back of your mind, as you're doing this, you always have to say, this is not a number. It's a concept, it's not a number. I talked to a couple of philosophy instructors, and it's like, we hate the way mathematicians treat infinity so casually. Like we just throw infinity around left and right. Like it's just nothing. Like you can't do that. Like, well, there was a mathematician by the name of George Cantor back in the 19th century. There's other mathematicians that also did a lot with infinity, but George Cantor was the one who like pretty much opened up the Pandora's box or the box of Pandora's of infinities and allowed mathematicians to treat them far more casually than we used to. Okay, so that's an issue. But when you want to say like tangent of pi over 2, that the correct answer is undefined. As x approaches pi over 2, then tangent tends towards infinity. In calculus, you're going to say, oh, it approaches infinity, which that's why books don't rate it because you don't approach infinity. Okay. It keeps getting further and further and further away. You're never approaching infinity. But we'll say tends towards infinity, grows without bound, something like that. Okay. So that's kind of how you reference infinity with how to do this. What the actual graph of this thing looks like. Okay. Here's my negative pi over 2. Here's my positive pi over 2. There's asymptotes at the negative pi over 2, asymptote at positive pi over 2. Here we're at 0. Here's my pi over 4. That value is 1. Here's my negative pi over 4. That value is -1. I probably should have thought more about this. Okay, so now that we can, we'll think more about this. -π/4 down here at -1. So the way that tangent looks, all right, for the shape of my tangent, it's going to look something like that. It kind of looks like an x cubed. That's how I want you to think about it. It doesn't because it's constrained by these asymptotes. It just goes up on and on and on up for forever. Whereas x cubed is not constrained, but they have a slightly different shape. But this middle shape, this middle part of the shape, x cubed would be a really good analogy for how tangent looks. Okay, so one of the things you have to remember is that the points that you need for tangent, right, are different than the points you need for sine, cosine, secant, cosecant. So remember, like these are different. The period for tangent is we have pi/2 minus a -π/2, right? My ending minus my beginning. This is going to be pi/2 plus pi/2 is equal to pi. So if I want the period of where tangent is, instead of that 2 pi/b for sine, cosine, secant, and cosecant, we're going to say this is pi/b. And that's how you're going to figure that out. Okay. Everything else is the same. Amplitude, same thing. Whatever number's out in front, that's the amplitude. You have a phase shift, you're going to have a phase shift. That's okay. But you have to be careful that the period you're using, the formula for period you're using is a little bit different. The points that you're hanging your tangent on are different than the points you want to hang your sine, cosine, secant, and cosecant on. Okay. So that's what that tends to look like. All right. Um, I want to back. Do we want to do cotangent? We'll do cotangent. So cotangent, okay, that is equal to cosine over sine. So at 0, right, we have cosine of 0, 1, over sine of 0, 0. So we're back to, that's a very unhappy number for math, right? We don't want 1/0. The same thing is going to happen. As we get close to 0, cotangent, right, is way up here. And if I look at cosine of theta over sine of theta, when theta is equal to pi/2, so we have cosine of pi/2 over sine of pi/2. Cosine of pi/2 is 0. Sine of pi/2 is 1. Oh, at pi/2, right, we're at 0. Okay. At pi/4, okay, cosine of pi/4 divided by sine, that's also cotangent of pi/4 is also 1. So here's my pi/4. Now, 3 pi/4, okay, so I'll get to why we're doing 3 pi/4. Where is 3 pi/4? Here's 1 pi/4, it's 45 degrees. 2 pi/4, it's a fancy way to say pi/2 or 90 degrees, pi/2. 3 pi/4, it's in quadrant number 2, 3 pi/4. Remember, all students take calculus. The cotangent and tangent are negative in the second quadrant. So when I look at 3 pi/4, we're going to end up with a -1. So here I have 3 pi/4. We're down here at -1. And when I finally get around to getting to pi, right, we have cosine of pi divided by sine of pi. Well, cosine of pi is -1. Sine of pi is 0. Like, uh-oh, can't do that. That's undefined. So just like tangent, there are asymptotes at 0 and pi. And cotangent, here's my 0, cotangent is the reciprocal value of tangent. So for cotangent, we end up looking at, we have a graph like this. All right. So the issue that you have to remember is that for tangent, the numbers that you want to kind of plot in are -pi. So this is for tangent. -pi/2, -pi/4, 0, pi/4, pi/2. For cotangent, we have to do 0, pi/4, pi/2, 3 pi/4, and pi. Okay, and those are different, those are the different anchor points that you're going to need to graph tangent and to graph cotangent. So be careful when you are graphing tangent and cotangent. Don't just go on autopilot and say, oh, it's 0 to 2 pi, because you're going to get the wrong answers and you get that question graded wrong. Tangent is different than cotangent. They both have a period, right, of pi/b, because pi minus 0 is still pi. pi over 2 minus negative pi over 2. So the periods are different. That one cycle is different length than the other four trigonometric functions. And you just have to keep this straight of like the tangent versus cotangent, which when you're graphing, they have different sets of numbers. And it's one of those things you're going to just have to commit to memory to say, okay, these are the ones that I need. Okay. So that's how you graph tangent and cotangent. We would do some more examples on the next video, but I think that was long enough for this video to go over tangent and cotangent. So at that point, I'll say thank you very much for watching, and I will see you in the next video.